Welcome back for lesson 1-4A. Today we're going to cover solving equations. And as always, let's look at our learning targets, what we're hoping to get out of this. So by the end of this, you should be able to solve equations and solve problems by writing equations. That's going to be our emphasis of today. So first of all, what is an equation? Well, an equation is a statement that two expressions are equal. All right. Don't really know why example is there. So, solving an equation. Well, that means finding all values of the variable that makes the equation true. How do we do this? How do we solve it? Well, we use inverse operations to undo the equation piece by piece. So example, you use subtraction to undo addition, use division to undo multiplication, so on and so forth. So we're thinking in terms of opposites, okay? So first, let's just revisit those basics. All right, so x minus 8 equals negative 10. Well, I have my variable x that I'm solving for, and I'm subtracting 8 from it. So what's the opposite of subtracting 8? Well, adding 8. We'll cancel that right off. Negative 10 plus 8, again, be very careful with this. You get negative 2. All right, 12c equals 18. So, undo multiplication, you use division. And your calculator is going to tell you that is 0.6 repeating. However, I don't like when you have infinite decimals. I don't like when you leave your answers in that form. So what I'm going to ask you to do, if you have a graphing calculator, and this is something, again, if these next steps confuse you, just make sure you ask me. But after you get that answer of 0.6 repeating, okay, I want you to take that, go to the math, and then you'll see this arrow fraction. All right, arrow fraction, we'll turn that into 2/3. When you're dealing with a repeating fraction, that is what I prefer. Turn it back into 2/3 for me. And here, I'll even put that you go into the math feature just so you remember. Now the next one has two things happening. I see multiplying and I see subtraction. Now, here, the interesting thing is we drill you with PEMDAS, but remember you're undoing this equation. So in this instance, you're actually undoing PEMDAS. That means you're going to go in reverse order. Now, what that means is I'm going to take care of that subtraction first. So I'm going to add that 1 over. And then I'm going to divide by the 2. Okay, so make sure when you have multi-step things, make sure you're doing it in the right order. Make sure you are truly undoing PEMDAS, okay? You're going in the reverse order. Remember, sometimes you have the variable on both sides of the equation. In order to combine them, you're going to have to add or subtract them to one side of the equation. Now in this example, before you can even do that, there's something else you have to do. And I really hope that you notice this, that you can distribute that negative 2. All right, so that's going to give us negative 2y plus negative 2 times negative 1. Negative times negative is positive. We'll get that. And now, again, that situation is happening. I have my variable on both sides. So what it means is I have to add or subtract it off of one side to get it to the other. I prefer dealing with the variable with a positive coefficient. So what I'm going to do is I'm going to add 2y to both sides to cancel it off of that side. So notice it completely removes it from that side of my equation. And now over here, 1y plus 2y is going to give me 3y's. Now we're back to the example that we had just done. Now to undo PEMDAS, I'm going to deal with that 16 first. So I'm going to add that 16 to both sides. Then I'm going to take care of that division. 18 divided by 3 leaves me with 6. And there is my solution. Now, as you know, it can get pretty messy, pretty complicated. So a hint that I'm going to have for you, what I'd like you to do, is consider that you can clean up an equation before you start even crossing over the equal sign, okay? That's going to be what I believe is easiest for you. Clean up each side before you start crossing that equal sign. So what I mean by that is let's distribute that 3. So 3 times 2x, 3 times 2 is 6, so that's 6x. 3 times -1 is -3. -2 times 3 is going to be a -6x minus 8. All right. Now, it's not quite cleaned up yet. That left-hand side of my equation can still be cleaned up even more, because look at this. 6x minus 6x. Well, that's actually kind of a neat scenario. 6 minus 6, done, gone. -3 minus 8. Well, -3 minus 8, those like terms are going to be -11. So don't forget the skill of distributing and combining like terms. That's going to be key in some of these problems. Now I have 11 still multiplying my x, so I'm going to divide by that 11. -11 divided by 11 is going to leave me -1 for my x. All right, so let's move down to the word problem for a little bit. So this map shows distances between towns in miles. You and your friend drive together from Newton to Essex. You drive first for a total of 40 miles. Then your friend drives 1.5 hours to reach Essex. What is your friend's average rate? All right, so thinking of average rate, well, think about how do we determine rate? Well, rate we usually think of as miles per hour. So we're going to be talking about the distance divided by the time. There's my little mental map of where I need to get to. I need to know the friend's distance they drove divided by the time that they drove. That will give me their average rate. All right, so how much did the friend drive? Well, it says that I drove for 40 miles. Well, how many miles are there? Well, 46 plus 44 plus 36. There's 127 miles to this trip. And again, it says that you already drove 40 of those. So your friend drove 87 miles. All right, so that's how much your friend drove. So what is their average rate? Well, if they drove 87 miles in 1.5 hours, that's going to be an average of 58 miles per hour. Right? And again, notice what I did there. I used the vocabulary of the problem to construct kind of a mental map of what I needed, and then I used the diagram and the rest of the problem to figure out what I needed in order to get there. All right, continuing on. Two special cases that can happen. So most of the time when I'm having you solve an equation, you're going to find an answer, right? Linear equations have one solution. However, there is the circumstance where the variable can cancel off of both sides. And if it cancels off of both sides, something very unique and special happens. Well, one of two things can happen. If you're left with a true statement, so something like 1 equals 1, that's called infinitely many solutions. So if you have 1 equals 1, 2 equals 2, 3 equals 3 left, it is always going to be true, meaning you're going to have an infinite number of solutions. Now, I do let my students write that as IMS, okay? So if you don't want to write out infinitely many solutions every time, if you put IMS, I'm going to know what that means. Now, what if it cancels off and a false statement is left? Something like 3 equals 5, 0 equals 1, so on and so forth. That is a no solution case, right? No solution will solve that equation. Nothing will work. And again, for those of you, if you want a shorthand, if you don't want to have to write out no solution every time, I will just let you put NS to abbreviate it. And I will know that you're communicating to me that that is a no solution situation. So let's take a look at two examples. So 11 plus 3x minus 7 equals 6x plus 5 minus 3x. So let's clean up both sides first. So starting on the left-hand side, 11 minus 7 is going to give me 4. So I combine those like terms. On the right-hand side, 6x minus 3x is going to leave me 3x, and then I have that 5. I see I have my variable on both sides, so I'm going to go and cancel it off. So to cancel off this one, I'm going to subtract 3x from both sides. Now, notice we get that situation. It completely canceled my variable out of the equation. All I'm left with is 4 equals 5. I'm left with a false statement. I'm left with nonsense, something that could never possibly be true. So it's telling me that no matter what x I start with, this will never lead to a true equation. And what that means is there is no solution to this equation. So let's take a look at the other side. Again, I see some cleaning up that can be done. I see some like terms that can be combined on both sides of my equation. So I see here 6x minus 2x is going to give me 4x. Here I see 4 plus 1 is going to give me 5. So again, really quickly, I'm just combining my like terms to clean it up a little bit. And now I see, again, I have my variable on both sides. So I'm going to attempt to cancel it off of one side. So I'm going to try to cancel this one, subtracting 4x from both sides. But I get that situation again. That ends up canceling it off of both sides. And I'm left with 5 equals 5. So this time, notice it canceled, but I'm left with the opposite case. I'm left with a true statement, something that is always true. So what that's telling me is no matter what x I started with, this is always going to be a true equation. So this is going to be one of those infinitely many solution cases. All right, any x will produce a true statement there. All right, so this turned out to be a little bit of a shorter video, which I hope you appreciate. So that is it for our notes. As always, what I'd like you to do now is please write out a summary. Please write out, reflect on the main concept of this. You can use that to answer the learning target, anything such as that. Or if you have anything that you're still wondering after this, you can write it as a question and we can discuss it tomorrow.